Okay, so now we're continuing with biological and chemical controls. So biological control is the intentional use of using living organisms to control a pest, and this could be insects, nematodes, mites, pathogens, etc. Conserving biocontrols includes pesticide reduction or elimination to prevent the loss of these organisms that are already in the area. And then augmentation is the release of natural enemies that you've purchased to control pests. So just some definitions here. Pathogens are disease-causing organisms. These are bacteria, fungi, virus, nematodes would be in there too. A parasitoid is an organism that during its development lives in or on the body of a host, eventually killing it. Parasites don't want to kill their prey. They want that thing to stay alive so they can continue to live off of it. So in this case, an example would be a parasitic wasp. A predator is an organism that live by preying on other organisms. An example would be lady beetles. That's our classic predator. So Beauveria bassiana is actually a biological control of many insects. It's a white muscadine disease that is actually found in soil. It's a naturally occurring soil fungus. When the spores come in contact, they germinate and grow directly through the cuticle to the inner body of their host. It grows through the insect's body, producing toxins, and drains the insect of nutrients and killing it. And this is what it looks like. Burkinid wasp, it lays eggs in this tomato hornworm, and you can see these are the cocoons from this Burkinid wasp. Okay, here's a close-up of the cocoons, and you can see the head of one of the adults coming out of one of those cocoons. He's continuing to exit to go on to infect others. And here they are, they're all empty. That caterpillar is no more. So of course everybody knows lady beetles are predators. Here we have an adult feeding on winged aphids. Here we have the larva on the right here feeding on some other aphids. They don't just eat aphids, but that's definitely one of their favorite foods. Lady beetle adults generally eat about 50 aphids per day. The seven-spotted lady beetle eats several hundred a day. And the larva of the seven-spotted lady beetle can eat as many as 200 to 300 aphids in a day. So it's really key that you protect these things from pesticide because they're going to take care of these guys for you. Okay, this is a syrphid fly, and the syrphid fly, it is truly a fly. It looks like a bee, but it's got two wings, so it's a fly. And the adult is not going to do any damage to any insects. It's actually more of a pollinator, but its larva feeds on aphids like it's going out of style. So if you can plant flowers that would attract the syrphid fly into your garden, chances are you'll be able to manage your aphids once they start laying eggs. So some of the plants you can grow to conserve these things, plants to attract. This is anise in the carrot family. This attracts lady beetles, green lacewings, parasitic wasps. The daisy family attracts hoverflies, lacewings, parasitic wasps, tachinid flies, bees, lady beetles. The mint family attracts syrphid flies, parasitoid wasps, tachinid flies, damsel bugs, and big-eyed bugs. Those are both predator insects. Legumes can, such as hairy vetch, could be a cover crop. You let it go at a flower, and it'll attract lacewings, lady beetles, parasitoid wasps, big-eyed bugs, damsel bugs, and tachinid flies. You want to avoid broad spectrum pesticides. Malathion will kill everything in its wake. Down in California, they used to, when a medfly would show up, they would be spraying malathion from the skies. They tend to do it overnight so it doesn't affect bees, but still, it's going to kill a lot of other things. Okay, Bacillus thuringiensis is it's a pesticide, but it's also a biological control. And this is, there's different types. The typical one that you're probably familiar with is dipel, which is going to affect the Lepidoptera, which are butterflies and moths. There is a type for Coleoptera, and then there's a type for which Coleoptera are beetles, and then Diptera are flies, mosquitoes, and gnats. So what happens is after it is activated within the gut, the intestine is paralyzed, the insect stops feeding, there's diarrhea and total paralysis, and then finally death. So it's a slow, painful process. So when you are going to use chemical control, you need to know your pest life cycle. You want to use selective pesticides first. You want to use the least toxic method. You control only where needed. Don't spray pesticide like it's going out of style. And if you are going to use a product that is not organic, it should have a caution label or less. So chemical controls should be the least disruptive to natural controls. It should be least hazardous to human health. It should be least toxic to non-target organisms, least damaging to the environment, and of course, most cost effective when you're looking at all of those things. And as I said, you need to know your pest life cycle. Here we have scale insects that are really challenging to deal with, but if you can spray them at the time that they are at the crawler stage, this is really the only time pesticide is going to work.